Okay, so Madison's going to fill a capillary. She's going to go ahead and stick that into the solid there. Probably don't need quite that much. Would you mind bringing it a little bit closer? No, you're okay. Just a little bit closer. Okay, so about maybe half that is probably about all you need. But if you've got more than that, that's fine as well. So about what she's got will be okay. Now, what she's going to do? Hang on, before you do that, I'm going to expand this out a little bit. And you can see that what she's going to do here is put the thing in through the top here, and then just let it bounce. There we go. And what will happen is, you can see, bring it closer here. See the effect here is that it ends up in the bottom of the capillary, which is what you want. So like I said, about half that is probably a good amount for what you need. You don't really need more than that. Alright, so here's the setup for the melting point experiment itself. You'll notice that Jen's got a thermometer adapter attached to the top of the thermometer. That's that grey thing. I'll zoom in on it so you can see it. Yeah, she's pointing at it. Now what's going to happen is she's actually going to clamp that into a clamp, and you can see the effect of that will be to suspend the thermometer in this solution of mineral oil. Now the mineral oil is going to be set up so that the thermometer is in about the middle of it, and you can see that that's what's happened here. I'm going to zoom in here so you can see exactly what's going on. Now you'll notice that we've got two capillaries there, and they've been tied to the thermometer with a rubber band, and you can see that they're set up so that the ends of the capillaries, where the material is right next to the bulb of the thermometer. You'll also notice that the bulb of the thermometer is not touching the bottom of the beaker. So you can see it's very important to have this set up the right way. So I'll zoom out here so you can see the entire setup. Clamped in with the thermometer adapter, and then in the bottom with the capillary setup. You'll also notice that these capillaries, I'll see if I'll zoom in, one of them is marked. Yeah, see, one of them's got a black mark on it, and that's smart because that allows us to determine which is which, because one of them is naphthalene and one of them is benzophenone. As long as you know which one's which, it doesn't matter which one you mark. Alright, so we've got both of the benzophenone and naphthalene here, and we're going to wait and see where one of them melts. Now when we're getting the melting point here, what we're trying to do is we're trying to see how, from when it starts melting to when it stops melting. So what's going to happen is this solid here will turn into a liquid. So the benzophenone is on the right, is that right?
Yeah.
Okay. So that's the one we expect to melt first, is the benzophenone. Okay, so we're at about 44 degrees. Now when we take these measurements, technically we should be measuring to 1 decimal place. And it'll either be 0.0 or 0.5.
Does it get like clear?
We're not that worried about the significant figures though, because we're more interested in doing a melting range here. So we're interested in when it starts melting to when it stops melting. Just to get you an idea, there's your measurement there. It's about halfway between 40 and 50 at this point. So about 45.
Where do you want to go to?
So we're keeping an eye on the one on the right here. We're expecting that to melt soon.
What's the temperature? So you do it here? 46.0. Yeah.
And what we're trying to do here is arrange it so that the temperature goes up by about 1 to 2 degrees. Well, between I'd say 2 and 3 degrees per minute is good. Now you can see it is beginning to melt. So I would start. I would take note of the temperature now at the beginning. So what you got, Jen?
46.5.
Okay, about 46.5. That would be my starting point. As you can see, it is starting to liquefy now. And once all of that solid has turned into liquid, that will be my finishing point.
Oh, that's crazy. It's like actually melting. Oh, I see.
Yeah, so you can see the liquefaction there.
We're just about at 48. It's doing it.
And it's just about there. There's a little bit of solid left in there. It is beginning to liquefy.
That's really quickly.
Yeah.
Because it's reaching.
There's some air bubbles in there, but there's no solid left. So I would take note of that top temperature. What have you got?
48.5.
Okay, so 46.5 to 48.5, that's what I would mark down for that one. Now we're just going to wait on the temperature to get up to the next one, which is going to be about 80 degrees. Alright, what we're going to do now is, now that the naphthalene and the benzophenone have both melted, Jen's going to take that off now, and she's going to quickly change out the unknown. Now the unknown won't melt until, well, it's going to be more than 110, so we've got a little bit of time to take this off, and you can see what they're doing is just taking off the rubber band, putting the unknown on, and then reattaching the rubber band. Now ideally what would have happened is that this unknown would have been prepared while the other ones were melting, so you wouldn't wait until this point to go ahead and make the unknown, because you won't have time to, take too long then to put everything on. But you know, these guys had it all prepared, ready to roll. So you can see that that's what they've done, and they've set this up exactly the same way. So we've got the thermometer adapter in the top, and you can see how it looks inside the beaker, and you can see that it's kind of close to the bottom of the thermometer, and it's we're going to wait for it to melt. At this point, you might want to turn it up to get the temperature rising a little bit faster, and maybe even possibly then slow it down a little bit once it gets to around 110, so that you don't miss any melting points. So these are the three members of one of the groups, and we're going to look at each of them closely, and we're going to see how we might make some visual observations about what these various substances are like. Now we could smell them all, but all the ones we're looking at tend to have not very much of an odor, so that's not really going to help us a great deal. So we're going to pretty much rely on texture and appearance. We're not really going to put these into our fingers, but we can look at these and get some indication of what they look like. So this one here, I would say is fairly fine crystals, and if you look at it, can you grab me a spatula please? So if you look closely at this, and we'll just move these around a little bit, you can get the impression that we're looking at something. It looks kind of like sugar. It has that consistency of sugar. So that's what I'd say for the first one. Also, the white color, it's more like a greyish white or an off-white than it is anything else. It is still white, but it's not that really bright white that some of these other ones might be considered being. So this one here, I'd say, is a brighter white. Now also, if you look really closely at it, let's see if I can zoom in here a little bit. I'd say that that's a brighter white than the other ones are. So you can make those kinds of comparisons. And if you look closely at this one, you'll see that that's really fine crystals as well. But the texture is a bit finer than the other one. I'd say that the other one was more sugar-like. This is more like, say, baking soda. A much finer consistency of crystals. And then this last one here, again, it's kind of a fine crystalline powder, and it's not quite as bright white as the first one we looked at. So there's differences between all of them here, and then you can look at your unknown and you can compare its crystals and its consistency and its color to the three here and get your best suspect that way. So we've determined here that the unknown is in group Z. So these are the three compounds from group Z. And if you could please hold up the unknown. Thank you. See, it's in a test tube there. And what Jen's going to do is she's going to pour a small amount of unknown onto two separate watch glasses here. Yeah, just going to move those out the way. And they've been marked A and B just so we don't get them mixed up. And we just want, doesn't really matter exactly how much you put on there. You might have to grab it out with a spatula, but that's probably good. That's a good amount. I like that. That's good. Alright, that's good. Okay, wipe off the spatula, please. Okay. Now, which one do you think it is out of those three? You think it's that one? Okay, so let's go ahead and grab that one. And I want you to put about the same amount on A. So that's what she's doing. She's mixing, she's going to mix this with a bit more than that, please. About the same amount. Alright, that's good. Alright. Go ahead and wipe that off. Now, now if you want to, for the second one, if you've got a second one that kind of looks similar, I'd recommend doing that. But if neither of them look similar, then it doesn't matter which one you choose. So she's just choosing another one to mix on B. And again, she's just going to use the same amount. That's good. Alright, so to mix the A together, she's going to go ahead and mix it using and crushing it as well. And mix it as well and crush it. Mix and crush, mix and crush. And then she's going to put some of that into a capillary. Okay, so go ahead and wipe off your spatula and do the other one now too. Okay, mix and crush, mix and crush. See, she's doing a really good job of mixing that. It's really important to mix these well so we get the effect that we're looking for here. Now, one of these capillaries is going to be marked, and it looks like that one's got a red thing around it, so we know which is which. The other one doesn't have to be marked because we know what that one is. So you can see what Jen's doing is she's going to put a portion of that. Have you got the glass rod? Oh, okay. And so while Bay is going to get the glass rod, you can go ahead and fill the other capillary. Alright, Cassie, why don't you go ahead and yeah, just do it there. So she's putting it in through the top like I showed you earlier. And we just want enough in the bottom so that we can see it. So about a 1/4 inch. You can bring it in front of the camera in a second. We'll see what it's looking like. How are we looking? Yeah, go. Could you bring it in front of the camera, please? A little bit further that way. Yeah. So that's a good amount. I like that. And then Jen's going to do the same with that one. Then what they're going to do is they're going to tie it to the thermometer, and now over here they're going to do some fresh oil. Not this hot oil that they've been using over here. They're going to use some fresh oil because we want to start at the beginning. And we can ramp up the temperature on this one and then maybe turn it down when it gets a bit closer to where we expect it's going to melt. Yeah, so you can see that they're now attaching both of those capillaries with the mixtures in them to the thermometer, the same thermometer as we were using. This time we're going to start with fresh oil. So have you got some fresh oil to go here? Okay, good. Should you put that in front of the camera? There we go. So that's fresh oil that hasn't been heated yet. The other one is off to the side here, and we'll put a coaster underneath that. Matt, would you please grab a piece of paper towel and put it underneath the oil you just took off?
We have it on a metal.
I prefer you put it on a paper towel. That way it won't leave a ring. Definitely won't leave a ring. There we go. That's what I like. Put it on a coaster. Alright, so it looks like they've been successful in getting the things on here, trying to push them down a little bit through the rubber band. Alright, that looks like that'll be good. Alright, put the new oil on. Remember, that's fresh oil, it hasn't been heated yet. And I think we can probably ramp the temperature up just a little bit here. And then we'll be ready to roll with that. Alright, so we're going to watch them. What we're expecting is that one of them will melt low and wide, and the other one will hopefully melt at the temperature we expect it to. So what I'm going to do is I'm going to show what happens to the one that melts low and wide, and we'll wait on that. It's about 50, getting close to 50. Now yours, you said your unknown melted at what? 150?
Between 149 and 150.5.
Okay, the one on the right looks like it's about to melt. Thank you. Yes, the one on the right looks like it's about to melt. So once we start seeing liquid there, and I think I see liquid already, I'd start measuring now. And again, we're looking at the one on the right here. Is that the one you're expecting it not to be?
Right.
That's good.
Okay.
Good.
151.
That's what we hope to have happen.
Yeah.
Now the other one isn't melting. That's good. It looks like this one has started. So where did it start melting, Jen?
Cassie, what did you?
It was at 128 when I.
128 when you looked. Okay. So we're going to wait and see. We'll see how long it takes to. Yeah, you can see that liquid up the top there, just barely. And that's what we have. That's what we hope will happen when we mix two things together that aren't the same. They end up melting low and wide as a mixture. Their unknown melted about 150, so we do kind of expect that mixture to melt lower than that. Yeah. So it's still melting. Very wide range. What we're seeing here. It's almost there now. So it started at 128. What's it at now, Jen?
It's about 145.
Oh, 145. Okay, wow. Yeah, that's certainly wide, isn't it? Yeah. There we go. So it looks like it's pretty much done now.
148.
Yeah, so lower.
142.
Yeah, lower 142. Okay, so 128 to 142. Pretty wide range. Yeah, it's definitely gone now.
I think the other one's just starting.
And the other one looks like it might be just about to start. So I would measure that one. I'd start measuring that one now.
148. Now it's at 148.
And it is in the process of melting.
Look at that. Fast.
And that was obviously a lot sharper. So I'd be pretty confident that the left one, because that was a mixture of their unknown with what they thought it was. And that is almost melted. Once that turns into a liquid completely, and it looks like it's done. So what's the
1.5.
okay? So what was the melting range on that other one?
148.5 to 151.
Okay, 148.5 to 151.5.
And then our unknown was 149 to 150. That's like almost. So it's very close.
So it's pretty close. Yeah, I'd be pretty confident that you had your unknown correct.